Stars so bright in the sky. On Arizona nights they fly. Nebulae in colors rare. Galaxies beyond compare. Sky tour in the night so clear. Brings the universe near. Real-time wonders to see. Streaming live for you and me. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. In the dark, the night unfolds. Stories of the cosmos told. Through the lens, a distant dream. Living real like a gleam. Far away, up so high. Across the stars, beyond the skull. Through the lens, a distant dream. Living real like a gleam. Lift your eye up so high. Across the stars, beyond the sky. Sky tour shows us the way. Every night a new display. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new. Lift your eyes to the skies, universe in all its light. Sky tours bringing the views. Every night feels brand new.
Hey, welcome everybody to SkyTour Livestream. It is I, Mark Antonio, here to take you along with Daryl Mason on another tour of the night sky. And by the way, we should say hi to Daryl. Hi, Daryl. How are you?
Hi, Daryl.
Hello,
Mark. How are you? Hello, everybody.
Well, it's great to have you with us, guys. Thank you so much. Hope you enjoyed that alternate startup tonight. That was original music that we composed. So tonight we're going to look at some really cool things and spend some time trying to dig into one particular nebula we've seen before and try and coax a few details out of it. That's the Tulip I'm talking about, Daryl. There's a faint nebula within the nebula, and we didn't catch it last time, but I think we need to use a higher sensitivity, which we can do, and longer exposure, which we can do. So we're going to try that and see what we get in a little while. Meanwhile, this is the Lagoon Nebula. Welcome to the Lagoon. It's a beautiful location. It's a stellar nursery, and it's powered by this star right here that you see. And I know it's hard to see, so I'm going to zoom in on it for you. I've been taking this picture for just a few minutes. I've taken a few shots of it so far. You can see I've taken actually 58 of them, but you can see that hourglass shape right there. It's very, very distinct. Okay, and that hourglass is the central region here, and in that hourglass, just so you know, is right inside that square. See that? Yeah. Okay, that hourglass is right next to a type O star. O stars are the hottest and bluest stars in astronomy and in the universe. And so most of their radiation is given off in the ultraviolet, which is something that we can't see with our eyes. It's way past the blue end of the spectrum into the higher energy frequencies. And so stars give off energy not just in the visible spectrum, but in the infrared, which is the heat we can't see, and way off in the ultraviolet. And so stars have a bigger range of wavelengths that they give off rather than just visible light. All right, you see the results of infrared down in the far red when you look at a hot road, and you see infrared waves rising from the road affecting the air. Okay, and because they affect the air, you see some crazy artifacts and shimmering that you see. All right, so I do want to first, before we get going here, I do want to say hello to the folks that are here. I believe Tim F made it first this time. Congratulations, Tim. Nice job.
He usually does.
Yeah, I know, but Vera beat him last time. But Vera can't be with us tonight. She told me privately that she isn't going to be able to make it tonight. I think that's the case. She might show up. Then we have Michael Hedrick with us, and we have Wild Ike. Hey, we have Wild. I think it says Wild Ike. I'm not sure what that is. Yeah, it's been a few, Wild. I wish you were. Wish you'd been around before. It's okay. We have Blaine 19. What's going on, man? Nice to see you. Red Angels back with us. Nice to see you, brother. And Sam S is joining us tonight. Catherine Messick. Hi, Catherine. Nice to see you. My buddy Science Bob is with us. Hey, Bob. How you doing? That's Bob McGuire. Great guy. Okay. And Rocket City's with us. Nice to see you. Susie Karasik. Hi, Susie. I'm glad you guys made it. And Daniel Whitaker's with us. Nice to see you. Again, if you guys haven't subscribed to us, it's free, man. Just subscribe. Click the bell. Drop it down. Say all notifications. And every time we stream, you get to come see this live. This is a live view of the Lagoon Nebula in the constellation Sagittarius. And this is a beautiful nebula, and it's a stellar nursery where stars are being born. We see a bunch of them here. Okay, this square here shows the source of much of the illumination you see here. This red is not just lit up; it's actually glowing. Okay, and it's hydrogen that has been ionized and made to glow red in the light of what we call hydrogen alpha. It's one of the transitions that the hydrogen atom can make. All right, so this is actually cool. So that said, let's take a look at some of the other outer regions of this as we zoom back out. Okay, look at that beautiful nebula. And you can almost see, let me just pull this black level back a bit just to actually get us some extra additional data. You can see in here where this hot star is, it's like I said, it's ionizing way out here, plus other stars are born in here that are doing it. And this nebula is full of this dark stuff. This dark stuff is dust from countless supernovae before, and old stars that have sloughed off their outer layers and made molecules in the cool outer atmosphere of the stars, and then sloughed them off to the universe. Ronald's with us. Hey, Ronald, Rocket City, how you doing? So I think this is pretty cool that this nebula is the first one we're going to use tonight. It's actually past the meridian right now, and I'll show you what I mean by that. Okay, if we zoom out a little bit. Okay, south is a straight up and down line. Okay, and it's a little bit past it right now, as you notice. So it's a little past it right now, and now the time out there is 8 o'clock in the evening. All right, it's actually 11 o'clock here. So we start a little early because we can now. It's going to get earlier and earlier as winter approaches. So it's really something.
Summer's going away fast.
I know it. It's just terrible.
Something you said a minute ago reminded me. You were talking about the hourglass in M8.
Yeah.
You said something about the ultraviolet.
Yep.
This might not be the place. Maybe you'd want to talk about it on your radio show sometime. Is the ultraviolet catastrophe?
Yeah, the ultraviolet catastrophe. Yeah, we've actually talked about that a little bit on the show, I think, Daryl. Didn't we?
Okay. I don't recall.
Okay. All right. Desert Adventures in Arizona. How you doing? Tiffany's with us. Hi, Tiff. Tiffany's one of our super fans. I guess I have to call you a super fan. She and Michael, who is known as Calabos, they provide us with equipment to give away exclusively here on SkyTour Livestream. So, okay, so now let's...
Bob gets it.
yeah, Plank would approve. All right, so we've done a lot of these here, so I'm gonna save it, and just so we can have a good starting value.
Nice pick.
Yeah, I started this before the sun had completely gone away. One of the things I noticed at this location out in the desert is that while you still have the red of sunset and even illumination of sunset clouds, you can still see the Milky Way. It's amazing. I've never seen that before. Usually you've got to wait for the sun to be completely gone and past astronomical twilight to be able to see. And that's about an hour after sunset or so. And you got to usually wait to see the Milky Way, but out there you don't. I have a photograph proving it. I photographed the Milky Way going all the way down into and merging with the sunset, which is kind of cool. And it wasn't a trick photograph. I did it literally with a camera on a tripod, and it was like a 25-second shot.
Yeah, but it was a camera shot.
It was, yeah.
I mean, you wouldn't see that naked eye.
No, you could. You could see the upper part of the Milky Way through Cygnus. Well, you couldn't see a tremendous amount of detail down in the Sagittarius star cloud, more toward the south, because there was still light down there. But you could see the Milky Way disappearing into it, and the camera pulled out even more detail.
Yeah.
Yeah, it was beautiful. So you almost don't have to wait until full sunset, astronomical twilight, to be over. It's really cool. You know? All right, so let's see. This is... I started this picture earlier because... and it's only a 12-second shot. Usually I do 20. But I wanted to do this just to catch... to see what I could do with detail for an image that's literally 93 stacked images right now at 12 seconds apiece. So that's it, and we'll say good. Now, right now, we just saved it, and what's happened is it's going up to the cloud and then going down to our server. You can find our server here at skytourlive.org right there. See, da-da-da-da. And you go there and scroll down, and you can find this image on our server. There's instructions how to get it. You can also, when we can release it, and this is becoming almost a joke for us, we're trying to get our app released that Izabela wrote. She's our amazing super user from Bulgaria, and she has written an application that shows years and years of SkyTour data all in one place, and you can search for every time we photograph that, for instance. You know, really cool, and it's very, very useful and helpful if you want to just look through everything, do comparisons to previous shots, because sometimes there's differences. Sometimes there's an asteroid that might be in a shot that wasn't in another, and it'll show up. You'll be able to catch it. And you might be able to find a new asteroid that way, so for an example. So we certainly haven't found all of them.
You know, I've actually been using the app. I didn't think I would, but I find that I do.
Now, see, it's funny. Just so you folks know, Daryl was a little hesitant to use it to begin with, not for any reason other than he was like, I don't know, you know. But he actually seems to be warming up to it now. That's actually the first I heard him say that. And that's really good, Daryl.
You know, in our chat, I occasionally post astro images from elsewhere, and I've gotten into the habit of checking the app to see if you. It's like I shared LDN 673 the other night, and golly, it turned out you'd already imaged it twice.
Yeah, Lynn-Stark Nebula 673. We'll do that again tonight too. Actually, we should go to it. We could go to it next, but I don't know if it's dark enough. We'll do the Trifid, and then we'll go to it. Okay. All right. We'll save this for a last time, like I already said I was going to do. I'm doing it again. Science Bob says, I'm thinking about putting my telescope in Texas. I have a friend in Tucson that supports observatories in Arizona. I'll figure it out soon. I'm missing it living in Maryland. Yeah, you are. There's no dark sky in Maryland, man. Not at all. Yeah, and then Rocket City says, I might buy some land in the middle of the desert and build a solar-powered observatory. That's exactly what we're doing. Yeah, man. Go for it. Ray's asking about using Sharp Cap, this application here that we're using to do all the capture in a different way. Hello, Lubo in China. How are you? Lubo wants to see the Helix Nebula. That's a planetary nebula. That's a star that's exhausted all of its hydrogen and shed its outer layers.
Might be a little early for the Helix.
It is. But yeah, Kevin O'Neill, how you doing? Springfield, Missouri. Hey, welcome, man.
Homeboy.
Yeah.
I was born and raised in Springfield.
How about that? See that you got a kinship with Daryl here.
Yeah, I got out as soon as I could, but.
Oh yeah, that makes him feel great.
I turned 21, and
oh yeah,
it was time to spread my wings and leave home. So I moved to Colorado. I've been here ever since, nearly 50 years now.
Yeah, you were in Leadville for a while.
Yeah, I was in Breckenridge. I was in Leadville. Now I'm in Colorado Springs.
Yeah. Yeah. All right. So we did that, and so for people that are joining us for the pretty much the first time, I'll just quickly go through this. Okay, this is our telescope control section here. Okay, so I control a telescope here. All right, this is our telescope computer. You'll see the display in the screen showing up quite a lot, and obviously there's the telescope in the building. There's usually another image here, but that camera's down, and then there's me. Hi. Okay. Down along the bottom here, you'll see a screen that comes up from now and then, and that's actually our stacking screen where we take images and stack them. That's why this nebula came out so great. Okay, this over here is the camera control cluster right here. Okay, the most important elements are the exposure and the gain. Gain is the sensitivity of the sensor of the camera, and the exposure is how long we're exposing that sensitive sensor. And that you can imagine how the play between those two numbers, a higher gain means more noise, so use a little less gain and a longer exposure, you get a nice shot, that kind of thing. And we play that game quite a lot. All right, so that's the layout there, but then we have one more addition, and that's this. This is our planetarium that's linked to our telescope, and this is how we navigate. We don't need to use it. We can use stuff over here, but this is a really nice thing to use. So I'll give you an example. We are looking at the Lagoon Nebula right here, and now we're going to go up to the Trifid Nebula right here. Okay.
Trifid.
I call it Trifid. I call it Trifid. Growing up, I called it Trifid, and then Trifid in college. When I was getting my astronomy degree, everybody called it Trifid, so I started calling it Trifid.
Yeah.
So I don't know. Try is try, so
Yeah, 3 lobes.
Yeah.
Trifid is an English monster movie, so
Oh,
that's the way
Day
I
of the
always look
Trifids.
at it.
Remember those?
Oh yeah, scared the willies out of me when I was a kid.
Yeah, how do they kill their plants? It's crazy. I didn't get it. But it was Day of the Trifids. Was a great movie. All right, we're going to go right up here. This is the Lagoon where we just were, right? And for the record, we are near Sagittarius. This is Sagittarius, the Archer, right here. You can see that. Scorpius, the Scorpion, is over here. And as Daryl has said many times, it's in that position where it just seems to hang in the sky for a bit Okay, we have Antares here, the eye of the scorpion, and then we have
Here,
huh?
the heart.
Heart. Well, they. Let's take a look here.
Trust me, it's the heart of the scorpion. I
Yeah,
don't care what Stellarium says. Antares is the heart of the scorpion.
fine. It depends who you talk to, I guess, and what planetarium you use. But then down here are these two cool stars. I think. Let me go down. They're right here. Oh, okay. We're getting a little.
Yeah, the cat's eyes.
Yeah, the cat's eyes, as you call them. Yeah. It's Shola, and
Liseth.
I'm trying to see it. Yeah, I'm trying to get it to show up.
Yeah, they make the scorpion stinger.
Yeah, and there's a cluster right near it. Yeah, there's Liseth right there, and Shola, and then right to the left is this globally cluster. It says, but that's okay. All right, let's go up to the Trifid Nebula. That brings back memories, calling it that. Okay. All right. Trifid Nebula, you'll like this. This is neat because it showcases a different types of nebula. Okay, and I'm going to tell it to go there now, and you'll watch the telescope right here. You see it move. Okay, there it goes. You see the stars moving, and the telescope's moving up now, just a little bit, and then you'll see our fuzzy ball. That's the Trifid Nebula right there. The telescope knows where to go. I aligned it all tonight to get it all set up. And now what I'll do is I will move this over just a little, not much, just one notch.
Is it really so different than the Lagoon? I mean, they're both emission nebulas. They're both excited by big hot stars in the middle.
Yeah, what makes this one different, though, is that it's surrounded by a blue reflection nebula, as you know. And this blue reflection nebula, coupled with this beautiful red nebula, is striking when you see it in color. So we're going to do that. And we'll go do a 25-second shot here now. See, I put the 25-second in the exposure. And now I'm going to kick it off. We're in low light mode. I'm going to go into deep sky mode now. And we're going to start our stack, and you'll see the Lagoon Nebula that we just did a little earlier. Look at that. That's beautiful. And we're going to clear that because it's done. All right. Hey, Queen Peachy Keen's with us. Hey there. How you doing? QPK. Marco's with us. Hi, Marco. Oh, and thank you. Daryl put up the server address. Yeah, there you go. That's the Lagoon. I'm sorry, the Trifid Nebula. You can see the beginnings of this blue nebula. This blue nebula surrounds this beautiful, nebula here. And a lot going on here, which we'll break down shortly. Notice it looks a little crunchy or noisy, and that's because we've only got one exposure here. As soon as the second one comes in, okay, then it starts to smoothen out because we're now taking the next image, aligning it with the first, and then stacking them on top of each other. And now what if there's wind? What if there's shaking of the telescope by the wind? Does it ruin our image? The answer is no, because what we also have is this filter in place. This is called the full width half maximum filter. And we have a setting on this filter set right now to just 8.19. And that means that the star's diameter is going to grow and shrink based on wind and vibrations. And we want only the smallest amount of vibrations. So at 8.19 and below, at this location in the sky, we will get a nice round stars. If I took off that filter, you might get elongated stars. You know, so we don't do that. We leave that on, so that's always going to govern how beautiful our stars look.
Elisha is here.
Alicia's with us?
Yeah, Elisha.
Oh, hey, Alicia. I'm glad you made it. Wow. That's cool. Elisha, as you call her, Alicia and Darlene, at the very least, are going to be going to Arizona in a couple of months, few months.
Oh.
Yeah, they're going to be visiting, I believe, with Marianne. They're going to stay at Marianne's. When is that, Alicia? And will Donovan be there? Donovan's her husband, a Texas cowboy dude that has the perfect beard. He's perfect. I've never seen a more perfect beard. Hey, James Small, what's going on? Okay. Oh, it's March for spring break. It'll be Donovan, Darlene, my mom. Okay, good. Renee is her mom. That's nice. That'll be March. I'm going to see about being there. I might be there too. Because we want to get the Benson, Arizona telescope finished. And I have a feeling I might be having it done well before then. But we'll see. I'm thinking of getting it done in November here. I have to be out there for a week or more anyway. So look at this. This is beautiful. This red nebula represents, I'll zoom in. This red nebula is an emission nebula. That is, the hydrogen gas in here is glowing red. And it's excited by these stars in here. And they're putting out ultraviolet light that kicks the electrons off the hydrogen atoms. And when the electrons rejoin the hydrogen atom, because they do spontaneously lose energy and come back in, they give off red light as they drop to that particular level in the atom. That's called the N equals 2 level for those who care. And that's the it's part of the Balmer emission lines in the atom. And this is the hydrogen alpha transition, the 656.2 nanometers. And this red nebula is kind of spherical shaped in 3 dimensions. And that's because beyond that, the star's light is not high energy enough to ionize the hydrogen that's also out here for sure. So that it's reached its ionization potential radius at that point. However, you'll notice that nebula has a shape to it that's kind of round and spherical, but this nebula is kind of all over the place. And you'll see that that's true with blue nebulae that you see in the universe, and that's because these are created by transitions of the atoms, okay, and they're energy transitions. And so once you get past the amount of energy that can actually do this ionization, it doesn't happen anymore. However, this stuff, this haphazard nebula, is caused by a different process altogether. It's not an atomic process. It's actually a reflection process. And more to the point, it's a scattering process. Here's how that works. The blue is actually dust. It's this black stuff, but in lower concentrations or where starlight is striking it in such a way that the dust loves to take the blue light and absorb it and re-emit it right away. It's called scattering. All right? And so small particles will do that. Small molecules will do that. The molecules in our atmosphere do that. That's why it's blue, right? So we see it here, and it's all over the place because the dust is all over the place. Look at this. It goes out here, it's out here, it's out there. We move around, you can see it. You see dust out here, okay? These are all dust lanes that are all in this region. Look at the knots of dust in here. This is actually quite nice tonight, Daryl. Look at that.
It is.
Really impressed with that. I'm gonna name
Make out
this.
the blue all the way around.
Yeah, and that's I'm gonna pop that in just a minute. Okay, and so to pop it, what I mean is to process it immediately just to show you kind of what's there is I do this. All right, when I punch it up, now you can see that we have a lot more blue in here. Look at it, it goes all the way out here. And I'm going to get rid of some of our darks here, bring the darks down here. So now you can actually see much better where that blue extent is. Check that out.
So the blue forward scattered light, is it also ultimately coming from the same source as the big star in the middle that's ionizing hydrogen?
Not necessarily, but it could be in part, because out here in this region, there might be more stars out here that are causing scattering. Let's give an example, and I'll leave us like this for now. Well, let's zoom back in on this. Let's say that this star happened to be at the distance of the nebula. We don't know that it is. It might just be brighter. But if this star was at the distance of the nebula, then its light could be causing, say, this scattering right here, or this scattering over here. This star could also be causing that scattering right there. It's a matter of how intense it is and how much of the star's light can reach this location. Just because this is pink doesn't mean it's opaque. Don't forget that. Okay? Because it's pink, it's glowing, but guess how many atoms are in a cubic centimeter out there? In this particular nebula, all right, I'll just drop it to here to make it more colorful. This particular nebula, a cubic centimeter is like, a centimeter, like let's say a cube of sugar, all right? In a cube of sugar size piece of space, you might have 30 or 40 atoms, okay? However, on the Earth, a cube of sugar space will contain 10 to the 19 or 10 to the 20 atoms. That's a absolutely incredible difference. You've gone from just a few to many, many, many atoms, many billions and billions of atoms. So the fact is, air is way more dense than these nebulae. It just looks like they're dense because you can't see through them. But the glow is across many light years. So if you were on a ship and you were sailing in a spacecraft right into the heart of this nebula, right? As you're going into this nebula, you'd be in here, and what you'll find is that the nebula, you might have this gentle pink around you at a distance, but you might not see much of anything in here. You wouldn't see the blue, You might not even know you're traveling through a nebula. So it's really, really cool. Hi, Earl. Earl's a first-time viewer. Show him some love, guys. Welcome, Earl.
I'll show him some like.
What?
I said I'll show him some
yeah.
like.
Of course.
He's not my type.
So this red nebula then, guys, is it's very sparse in there, but it looks it. But there's many light years across here. But make no mistake, if it's hot enough to be ionizing hydrogen out here, it is a very, very hot region. Now, I had a little discussion about this with someone earlier today. In space, there is no temperature. Okay, temperature is not defined in space. In space, things either absorb radiation or they emit radiation. Okay, and so the thing that's interesting is particles of dust can absorb radiation, all right, and emit radiation. So when we look at this with an infrared telescope, this will look warm, all right. The hydrogen gas, okay, is going to be heated up as well. And if we can look at the gas, we would see that it's also warm. So that's a really interesting feature of the universe. In between the atoms, there's not a definition for temperature per se. Okay, and this is dust. These are conglomerations of molecules that form particles of dust around a micron in size. They're very, very small particles. Yeah, this is great. We've only had 3 rejected shots. Let's go check it out. So see, I had this threshold with this blue line set to 8.19, but we had an errant shot come through at 9.48, 8.22, 8.33. What does that mean? It means that the stars were a little bit oblong and they got rejected. And only the round stars were allowed in, and that's why the stars look so nice in the image here. All right. So,
8.33 what? Arc seconds?
I think that, okay, yeah, that's a good question because I think that it's, well, let's go to the drift graph. That'll tell us. Okay, so when we're looking here, it looks like we're talking pixels.
Oh, okay.
I think it's pixel drift.
Oh, that makes sense.
And we want that number to be as low as possible. Now, we have lots of pixels in this camera, almost twice as many as our previous camera. So we're seeing more detail. Sorry, Daryl, hang on. We're seeing more detail in these objects than we've ever seen before. So we're in our glory. Go ahead.
When you're picking a camera for your format, I mean, isn't like 1 arc second per pixel ideal? Or does that depend on the...
Yeah, I mean, it would be, but that could be oversampling, I would think. And that's fine. I mean, you'd rather be over than under, you know. But it's going to be a lot of wasted pixels, wasted sampling. This particular camera is the ZWO 183 MC Pro. It is, for this particular telescope, it is actually a telescope that has a focal ratio that is like just under a tenth of what it should be. It was an f10 telescope for those who know photography, and we made it f1.8. So it's a very, very fast telescope. We see something in seconds that takes minutes to acquire. That's why SkyTour Livestream is so incredibly successful with our objects. Look at this beautiful object here. You know? All right, we got some questions here. Let's go back and look here. Did I see Martin here? James Small has a question.
I just answered it.
Oh yeah, that's it. Podcast UFO Live. If you haven't seen Podcast UFO, all right, that's Martin Willis, good friend of mine. I've been on his show many times. Martin Willis is a phenomenal guy. Remember when we had the Chinese balloon that went over? Martin caught the moment with his camera looking at the balloon. He caught the moment when the aircraft shot it down. And he captured it being shot down and falling from the sky. It was a beautiful video. Amazing. Martin he's the guy, man. He's always on the scene. So check out Martin Willis, Podcast UFO. Check him out. Subscribe to him if you haven't. And watch that show because he's always got some great guests on there. I want to have him on with us on SkyTour, you know, at some point. All right, James Small thinks he has a dumb question. He says, how many light years approximately across that pink area? Well, James, that's not a dumb question. In fact, I wrote a computer program to help us figure that stuff out. If we know the distance, I can measure this distance in arc minutes and then convert that to light years. So we're probably looking at about 20 light years here, which is just under the size of the Orion Nebula at 1,500 light years away. So just about.
This is, I saw 2 different numbers for the distance of the Trifid. It's either 4,000 or 5,000 light years away.
Yeah, that's why I was kind of, saying about, because there's a variation of distance numbers that we have for it. You're absolutely right.
Well, the Lagoon is supposedly 4,000 or 4,100, and 2 different numbers I saw for the Trifid. One said 41, one said 5. So
yeah,
if you can visualize the sky The Trifid sits just above the lagoon, and it's probably a little farther away.
Yeah. Okay, I'm going to move this and give us a full view for a moment. Look at that. That's our full view, guys. You can see other beautiful nebulae in here. These are called diffuse nebulae, a beautiful star cluster here. And let's see if we can identify these, shall we? I'm going to do a solution here. There we go.
Our cluster is Messier 21, isn't it?
Yes, it is right here. Yep.
Yeah.
So this is another feature we have. It's called annotation. We actually annotate, and you can actually see what you're looking at in the field of view. All right. This is stars. When you see these little plus signs, they're for stars. The HIP catalog, that's Hipparchus. That's the Hipparchus catalog of stars. Many of the Hipparchus stars are, in the 5th magnitude range, okay, but they can be a little fainter as well. Then we have other catalogs. There's a Tycho star catalog, and oh my gosh, Bonner Dirk Merstrung, the German catalog. It just goes on and on. There's many, many catalogs. If you remember, if there's some of you out there that were doing astronomy as kids and as amateurs, you might have a chart system called Scalenate Pliso.
I have it.
I have it too. And there was Will Tyrion's Star Atlas. And that was a full color. That was a beautiful one. Really cool. All right, so we're going to save this annotation as well. So when we save it, it'll be in that directory. So if you want to use it and look it up, you'll be able to actually be able to do that. So let me just bring this up. Bring it up. Here we go. Okay. So we're going to save the image with annotations. So you'll see a little green bar across the top saying that we did. So there it is. So what do you get? So if you go to the server, this is the image you're going to get right here. And this is one that you can download, use for free, and you get it. You can actually take the image that we're taking right here. Okay, when we save it again, we say save. All right, we're saving an astronomical file format right now. That's called FITS. FITS format is one that's actually really important because that allows us to do processing and then save exactly as seen. And now this is the one that people like as a pretty picture, and that's going to be this guy. I'll show you right now. This is what you can go and download for free right here. All right, and that'll be on our server, and you can get there by just going, guess where? Right there. SkyTourLive.org. All right, so that'll be that. That's annotations up there. And let's we'll redock this, and then I'm gonna bring my telescope back in here. It almost didn't see me swipe. Okay, so now we'll save this one more time. We have 40 of these and 41. So now we got 41 exposures. Save it exactly as seen. That's a beautiful Trifid nebula. Okay, now we're going to go into low light mode again and look for something different. I think I know where we're going to go. One more object before we go up to 673. And let's go to our nice thing here. Actually, you know what? I just changed my mind. We're going to go to M22 first. This, we've seen nebulae now, and now we're going to see a star cluster. And this is a really, really cool star cluster. It's called Messier 22. It's a globular star cluster. It's one of Daryl's favorites.
It is.
It is. You told me so.
Well, it sits there just above the junction of the teapot's handle and the top of its lid.
That's the lid of the teapot right there.
Caus Borealis there is the top of the lid of the teapot. It's also the top of the bow of Sagittarius.
Yeah.
Caus Media is the middle of the bow. Caus Australis at the bottom is the bottom of the bow.
Here's Caus Australis. Yeah.
And
Yeah.
the tip of the spout of the teapot is Al Nossel, which is the arrow.
Right here. This guy?
The star there, yes. That's the tip of the spout of the
Oh,
teapot.
nozzle, yep. All right. Okay, so now while we're here, I'm going to turn off the constellation art. I'm going to do something else here. We're going to center this up. Now I'm going to show you our field of view. So here is our field of view. This is a red square that I put in here, and it is 1 degree 29 arc minutes, which is 1.5 degrees across by 1 degree tall by 59.62 59 minutes 62 seconds. So this is 62. So 59.6 is, in other words, basically a degree. So it's a degree and a half by a degree in size, and it's pretty cool. All right, so now we'll come back here. There's that beautiful cluster. We're going to just move this up a little bit, center it up, and then we're going to move us a little bit to the east to center it up. And I'll just drop it down a little bit. You want to bring it, it's kind of close to the center here. There we are. Okay. I like centering them up. This should be good. All right. All right. So now what we do is, now you look over here and we're going to start seeing, it's saying searching up there, and then you'll see numbers. That's when it's guiding on a guide star. All right. And sometimes it doesn't bring up the numbers on time. It did in this case. Okay, we're going to do a 15-second shot here. You notice I put in 15,000. I could put a 15s for seconds or 15,000 milliseconds, which is 15 seconds. There's 1,000 milliseconds per second. So this is low light mode. Let's go into deep sky mode. And this is our previous guy. We're going to get rid of it. It's up on the server though.
Yep.
And now we're going to see Messier 22. Look at that beautiful image. And this piece kind of is very nice. Piano piece. So, this beautiful image, Messier 22, we'll let it come in. I'm going to take off this sharpening. We don't need it for this. Zoom in a little bit. We have hundreds of thousands of stars in globular clusters. Sometimes even more, way more. And it's thought that maybe there's a black hole in the center of these now. And, you know, we're still looking at that. We're not sure. But it's possible that they're held together by some black hole in the center. Nothing like a supermassive black hole in the center of a galaxy, but something a little smaller. And when would these have been created? Well, a certain number of black holes were actually created with the Big Bang. So it's possible that these black holes have always been here. Interesting how that works. You know? Hey, Fantasy, what's going on? And Shaka, what's going on? Nice to see you. Lubo in China has a philosophical question. Did you address that or not?
A little bit.
Okay. Where would people where would people in their understanding of science be if we live on a cloudy Earth without a chance of seeing stars or moon? Has anyone done this research? Actually, a very good question, Lubo. That's an excellent question. We wouldn't know our place without getting above it, and so we would wonder if we could ever get above it. So just like trying to break the sound barrier, we probably would spend some considerable effort sending probes above the clouds. And doing so, we might actually note that, hey, this is a planet, and check this out. There's something else out here. There's a whole universe. And that might spark an entire spacefaring thrust, so to speak. And I think that'd be pretty cool.
Might scare them back under the clouds, too.
It could scare them back into the clouds as well.
I mentioned in the chat, I think I have seen this question addressed in a way, science fiction before. Isaac Asimov comes to mind.
Yeah.
Been a long time, though.
Yeah.
I would think as long as you're under the cloud, your whole world, your whole universe is inside that cloud. And maybe science, maybe they study the weather more. Who knows?
Yeah. Yep. And it makes sense that they might very well end up achieving space flight before another civilization because they're so intrigued with getting off the planet to see what's up there.
Michael Hedrick has a question I'd like to address, please.
Okay, and read the question so we know.
He says, okay, then my question is, was Hubble the one who convinced people that galaxies are not nebula? He supposedly proved the nature of external galaxies, yes. So-called, the first good looks at galaxies astronomers got were with the first big telescopes. They did not know what they were. They called them spiral nebulae.
Yes.
And Hubble, he was looking into a thing called Cepheid variable stars, which Cepheid variables are a kind of star whose period is related to their brightness. That they're variables, they get brighter, they get dimmer. But if they time how long it takes them to cycle from like dimmest to brightest and back, perhaps, there's a direct relationship between the period and the brightness they achieve. And Hubble was using the 100-inch telescope, I believe, at the time. He detected Cepheid variable stars in the Andromeda spiral nebula, what we call Messier 31 Andromeda Galaxy. He identified Cepheid variables in Andromeda, and by measuring their brightness at whatever distance Andromeda is, he determined the true distance of Andromeda, and thus its true nature, and proved that it is an entirely separate galaxy from the Milky Way. He sort of opened up the universe to everybody by doing that.
Yeah, it started us on the journey down up, so to speak, the cosmic distance ladder.
Hubble's another homeboy. He was born in Marshfield, Missouri, which is a little town northeast of Springfield.
Oh, wow.
And he got out as soon as he could, too. He was quite a mover and shaker in his later years. I don't know if he ever went back to Marshfield or not.
Yeah, I mean...
He hung in pretty rarefied circles.
I think it was 1929 when he made some significant discoveries. I have to look back and see. This is gorgeous. This is looking really pretty. So we're going to name it now. This is called M22, and it's a GC, a globular cluster. There we go again. All right. There we go.
Every globular you see is different, too.
Oh, yeah. I want to point something out to you, too, Daryl.
Yeah.
If we zoom in really good here, we have this direct line of stars here. Look at that.
Mm-hmm.
Yeah. Now that's undoubtedly a line of sight issue. Those stars might not even be in this star cluster. But these are halo objects. They orbit the whole galaxy. They orbit as a whole. They go through, plunging through the disk and up through or around at farther distances, closer distances. So this one is not too far from us, relatively speaking, and it's heading kind of right through the central disk of our galaxy. So when they do that, it's possible that they bleed some stars off or pick some up as they go through. But when we look at these stars with a in a spectroscopic manner, in other words, look at their spectrum they generate, we find that the chemical composition of these stars is very simple. It's mostly hydrogen and helium with a few other trace elements, but not much more than hydrogen and helium. So that led us to believe that when these stars were formed, they formed early on in the universe, and it turns out these stars can actually be on the order of 12 billion years old or more. So these are among the oldest stars in the universe when we look at these, globular clusters. And we call those population 2. Okay, you would think that earlier means 1, later means 2. No, we're astronomers. We like to confuse you. Now, population 2 stars are the earlier population. Population 1 stars are, stars like this one here and that one there. The stars that are more recent and not tied to any particular, tied to like young formation, hot blue stars, stars in the Pleiades. Those are population 1 stars. Betelgeuse and Rigel are population 1 stars. The whole belt of Orion, population 1. Very young O-type stars, very, very hot, O and B. So there you go. That's what happens with these. So this is Messier 22. We can actually annotate it as well. Let's see if it'll give us our. Yep, you got it. No, sort of. Hold on. Oh yeah, we have this IC object over here. It's an association of stars. Let's go down here. And then we have Messier 22 here, centered. So that tells us that. That's good. We'll save the image with annotations. I like being able to point it out. Go ahead.
James Small has a question I'd like to address.
Okay, read the question.
With all the telescope technology we have, why can't we zoom closer to the moon, like to see rover tracks, etc.?
Oh, yeah.
It's pretty much laws of physics, James. Laws of optics in particular. There is not a telescope on Earth that can see the Apollo landing sites, for instance, or see the lunar lander there, or the lunar rovers, or the tracks, or the footsteps. It's just a physical impossibility of the nature of light and optics. There are telescopes that can see them, though. There's the Lunar Reconnaissance Orbiter.
That's right.
It's not a very big telescope, but it's really close to the moon.
It's only 60 miles up.
Yep, and they can easily see the landers, the footsteps, the tracks, the rovers, everything with the LRO.
In fact, I'll do a stream in the not so distant future here. I've done it before, and it uses the LRO Quick Map, which allows you to see the lunar rover tracks and see the experiments on the moon, the base of the lunar landers. And if we have time, I'll actually show you the crashed lunar modules that were discarded once they got back to the command module in orbit around the moon. Because they were set adrift and they spiraled in a very shallow orbit back to the moon, and then they hit mountaintops and then just blew up like balloons and scattered debris over miles. And you can actually see the scars of the impact. I found them. Really cool. Yeah. All right, this is good. This is Messier 22. Really looks nice. The other thing, too, is I did a calculation using the Hubble Space Telescope's size of its sensor. And for all the pixels on that sensor, the lunar landing site for Apollo 11, for instance, would take up just about half of 1 pixel, the entire site. So, unfortunately, it's meant to look at distant objects easier because close objects, it just doesn't have the resolution to see something that small. I'll give you an example of how the universe is big. Alpha Centauri is the nearest star system to us, the nearest, okay? And the stars are roughly the size of our sun, all right? And if you had a quarter, a 25-cent piece, all right, American 25-cent piece, about that big, how far away would that have to be from your eyes to see the disk of that quarter at the actual size that Alpha Centauri appears in the sky? Okay, think it through. Take that quarter and go away from you as far as you have to so that the size of the quarter is seen by your eye. The size of the quarter is the same size as the actual star Alpha Centauri in the sky, the nearest star to us.
700 miles.
Well, yeah, I was offering that as a question.
I answered it.
Yeah, it was a question for everybody else.
Okay, never mind.
It's actually a little over 700 miles. It's like 726 miles. But imagine that. It has to go that far. Right? Fantasy says 4 miles. Even that, that is amazingly close. You'd have to go all the way down, from, let's see, 726 miles. Draw it on Google Maps and say, wow, you got to stand with a quarter out there, and what telescope on Earth could see the disk of Alpha Centauri? Not a single one. However, we can see stars way further away and see their disks. You know why? Because they're big, right? Betelgeuse is an example. If you put Betelgeuse where the sun is, it would go out at least to Jupiter's orbit, maybe a little beyond. Antares, the heart of the scorpion that we were talking about before, same thing. It would be out by Jupiter or so. And both of those stars are destined to go supernova at some point. Gosh, I hope it's soon. I hope Betelgeuse already went. Okay, let's save this.
Don't say that.
Oh, I want to see a supernova close by.
Oh, I'd like to see a supernova relatively close by, but, Betelgeuse blows up, it's gone forever. That changes Orion.
Well, 4 million years ago, Betelgeuse was a blue star before it went to a red giant phase. It was an O star. So it was bright blue. So Orion didn't look like it does now with that red star up in the upper left. It looked blue, 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 blue. And blue through the belt. Actually, 4 million years ago, it was 4 blue stars and only 2 stars in the belt. Because one of them is younger than 4 million years. And so it actually appeared later. That's pretty cool. All right.
Cosmic Ray said, then how does JWST ID a 3-pixel red smudge as a galaxy 13 billion light years distant? I said spectroscopy, I assume, is the answer.
Well, again, looking in the far infrared gives us different types of clues. That little tiny smudge, that distant, okay?
That and redshift.
Yeah, it's a galactic redshift. Cosmic redshift is huge. We can see redshifts way far out than higher than normal. I think they were looking at redshifts up to 22 and 25, for some of these galaxies. Redshift is a factor. Again, you can thank Edwin Hubble as well. But redshift was actually very important because we discovered that the farther galaxies are from us, the faster they seem to be moving away from us. Now, this led to the expanding universe theory of the universe. And I liken it to, you say, every object in the universe is moving away from every other object. And you say, well, how can that be? Think about this analogy. You blow up a balloon till it's like a softball size. You put little black dots all over it with a Sharpie. Now you got a pockmarked balloon, all kinds of black dots. Some of them are close, some of them are far. Now you blow it up. As the balloon gets bigger, every one of those black dots is moving away from every other dot. Okay? That's the analogy for how the universe expands. Think of it that way, and you'll never go wrong. Okay? All right. We're going to...
Or you could do it in 3 dimensions with they use the raisin bread analogy. Imagine you make a loaf of raisin bread, and as it rises and bakes, those raisins all move farther apart from each other.
Yeah.
And the farther apart they are from each other, the faster they move away from each other.
Yeah. Let's see. Michael Hedrick, UFO coin series on money metals? No, I haven't seen it. But thanks for letting me know. That sounds cool. Okay, we did this. It's now dark enough for us to go check out Lynn's Dark Nebula. And let's just come here.
673.
Yeah, I'm just trying to... Okay.
It's in Aquila, isn't it?
Yeah, it is. I'm trying to get my search screen here. Interesting.
Starlink hanging up.
No, I'm live. I'm full live. I'm just trying to do my search here. There we are. Okay, LDN 673 right there. Okay, so just a little north of where we are, we're going to go here to a relatively innocuous piece of sky. But first, we're going to go to this star, and I'll show you why. This is Okab. Okab Deneb al-Okab Australis? Deneb al-Okab Australis. Wow. Interesting. I don't know if that's the tail of the eagle, do you?
Not as I understand it. Deneb means tail, but
Yeah.
I mean, if you turn on the artwork there, you'll see the shape of the eagle.
Yeah, and down...
But that's stellarium. So
yeah, Stellarium has this weird...
Sucks all by itself.
Yeah.
The tail of the eagle is right there.
Yeah, right there. Okay, so let's see. We should have a bright star in here if we're relatively close. Let me drop us down to fit the width. There it is. Okay. All right. So what I'm going to do is center that up, and when I do that, we're then going to synchronize. Make sure we're all set for this location. So this is Deneb al-Okab. The artwork is the artwork. What can I say?
Fantasy says tail of the dog. Perhaps that's an Arabic constellation. I know Aquila is Latin, I assume.
It's for the eagle, though. Yeah. Okay, let's synchronize computers. Let's synchronize systems. We are synchronized. Okay, so now we can get rid of our synchronization reticle. Now, when we go to this LDN number 673, we will find that we have... Oh, duh. Hello. We will find that we have a very exact placement because it's right there. So let's move over now. You'll see stars, and you'll see like a lack of stars. And that's kind of interesting. So watch this. Interesting. there seems to be no lack. There's like a lack of stars here, and there's a reason for that. And let me just do a 25-second shot here to get us going, and I will just stack it to. You'll see the previous guy. Yep, clear. That's how Omega Centauri would look. All right. So
awesome, and James Small. What that boils down to ultimately, the moon is about a half a degree across, or about 1,800 arc seconds, and that's 2,000 miles across. To look at like one of the Apollo landing sites, well, that whole site might be 100 feet across.
Yeah.
100 feet against 2,000 miles. I mean, you're talking a fraction of an arc second, and you're getting down to resolution limits there.
Yeah, you are.
Telescope can't resolve it that small. An earthbound telescope can't resolve it that small. But the LRO can.
Yeah, we have a nasty little problem called the Dawes limit.
Yep.
All right. Hey there, Awesome. How you doing, man? Awesome Hippopotamus. I like that. Good name, man. Awesome Hippopotamus.
I mean, I can see the dark nebulosity already.
Yeah, there it is, right there. That's. Now, Lind was another guy like E. Barnard who actually cataloged dark nebulae. He also cataloged bright nebulae. So we have Lind's Bright Nebulae catalog, LBN, and we have Lind's Dark Nebula catalog, LDN. So this is LDN 673 right here. Now you see me gesturing this way as well as this way to the image that you see right there. Well, the reason is because I have a big curved screen in front of me, and the observatory feed is right there, and the broadcast feed is there. So if I look this way, I'm actually looking at the same screen you're seeing right there. All the controls and everything, so it's all the same stuff.
You said something earlier privately about possibly shooting a dark nebula mosaic. Is LDN 673 so big it won't fit in the field?
Yeah, it's not in the whole field right now. If I scroll down, you see there's some more down here just below out of shot, and you'll notice there's going to be some over here, and if we go back up to the top, you'll see there's something else going on up there that's out of shot.
Yeah,
but it's okay. This is good. This will be the second time I did it. I did it alone yesterday, just to see if it is worth it, and it is.
This is probably worth letting it build up for quite a bit, because I know that image I sent you and Izabela the other day, they really caught the dark nebulosity well.
Yeah.
And you can see the cloudy nature of it. In fact, some parts of the dark nebula weren't that dark. They were actually showing some dim reflected light around the edges.
Yep. And every now and then, guys, I'll go over to this. This is called a histogram, where you see the levels here. You have the red, green, and blue, and the white curve is the average of them all. Same thing here. You have red, green, and blue. And you see the color responses are a little shifted at this end. And so what I'll do is I can align the color curves so it lines up the color curves at the peak. So the closer we are to the peak, the more correct the colors will be. And the darkest we'll get at the very top of the peak, we'll get the darkest background without losing detail. And you'll notice that it's a subtle red glow. That's because we have diffuse nebula here. And so this is one of those dark nebulae. It's LDN 673. Lynn Stark Nebula 673. And this is the first time we shot it with this. Yeah, you need to do something.
I'm sorry, just excuse me a moment,
Yeah,
please.
go ahead.
Be right back.
So Lynn Stark Nebula is actually a one of the many dark nebulae in the Lynn's catalog that he created. So I want to see if I missed anyone here. I said hi to you, Fantasy. I remember that. All right, and I'm just looking here. I think we got everybody so far. Martin, Podcast UFO. Folks, make sure you check him out. All right. I'm glad you can stick with us for a little while, Martin. I know it's after midnight now. And you're still East Coast time, so it's the same time as me. All right. You have a good night, Martin. So good to see you, brother. And come back anytime you want, as you know. Martin was actually here, and we did his podcast UFO right from here, from our control room. It was nice. All right, let me... Oh, here we go, yeah. By the way, we're going to... once I get it worked out, we're gonna the background tracks that we have here are music we get from YouTube's vast archive, but we're making our own, and so we're gonna have our own music. Like you heard that introductory song tonight, that song was an original, and we're going to be having a lot of instrumentals like this, but in the background, and they're going to be all original music. So we'll have the music of SkyTour too that we'll make available if folks want it. Okay. This is a gorgeous little nebula, man. Let me see if I can... Let's do this. Try to drag out a little more detail. Now I'm going to go to this one here, this histogram, and I'm going to hit that and kind of pump it up a little bit so you can see the extents. Now, typically we don't want to pump it up like this because that's now really over processing, but it shows the extents of what's there. So we're going to let it go a little bit and see what we get. Oh, James, thank you. He says this whole crew / community is awesome. It is, man. It's a wonderful. I started SkyTour live stream just as me out in my front yard years ago, and I had another co-host, Amanda. She was wonderful. Daryl joined us a couple years later and has been with us ever since. And we have some real super fans out there that have joined us and so forth. And I won't, Sam, thank you. He says, don't forget the copyright. So it's pretty cool.
You got some noise going on? I see some horizontal lines going across the lower half of the screen.
Yeah, you may be seeing something real. I'm not sure. It might also be an artifact of the feed, the observatory feed. Let's go see here. I changed the quality a little bit of the feed.
They're artifacts. They're like parallel dark and bright bands.
Here?
Yes.
Yeah. Might be a compression artifact for display. Might be actual. I have to see once we get the processing.
Yeah.
Now we're only doing a 25-second shot, and we're only at a gain of 180. We're not even at the 250 like I would normally do. So, and it can go to like 400. So, but if you do 400, oof, that gets a lot of noise. We could try it. We've done 22 of these. I'll save it. And you want to keep the parameters the same. So what I'll do is I'll start it again. And we'll try it again. So this time what I'll do is I will pump up this. Let's go to the max. Max is 450. And let's see how that works. We're going to get a lot more noise initially, but we'll give it a try.
You're a madman.
I'm a madman. So that's
The whim of a madman.
That's right. It's the whim of the madman.
Who said that?
I don't remember. It was a movie somewhere.
Yeah. Dennis Hopper in the movie Speed with Keanu Reeves and what's her face?
Yes.
The whim of a madman.
Yeah, that was. Oh gosh, I can't remember her name. There's a first movie.
Yeah.
People in chat will know who she is. I can't remember her name.
Cute, dark hair,
Yeah,
pointy nose.
Yeah.
Miscongeniality.
Yeah.
She was Sandra Bullock. There you go. Thank you, Sam.
Thanks, Sam S. Okay, our full width half maximum filter is just out of reach here. Let's see if it comes down. We might be getting some wind, guys. Might be. Hey, James. I know Travis. We're actually good friends. Travis Walton. He's a really good guy. Actually, I talked to him. What's nice is I can talk to him about astrophysics, and he doesn't get lost. He can actually hang, I mean, he get over his head eventually, but he's actually a really intelligent guy. Every time there's a conference and he's there, we hang out. We go hang out. It's a nice guy. Okay, it looks like if this one comes in red, I'm going to increase my...
Stupid question. Setting the gain so high wouldn't do that, would it?
I don't believe so. This is just guiding.
Yeah.
So that wouldn't do it. I think... well, actually, no. Let me correct that. It might do it, because that's what we're going to get. Okay, so let me go back here and see if I can get some kind of value here. Okay. All right, so I set the level. That's better. So now what we'll do is pull this down, pull this. Okay, again, these are our curves. All right, and when you color correct these curves, all right, then you get a proper color, and this white is the average curve, and this is the black level. If I move the black level to the peak, that's as dark as the background can get, right, without losing data. Okay, and you got to color correct all along the way because you're changing parameters. right, so this is now already showing more detail than we had in the previous shot. But we're at 450 gain. That's way up high. That's a very, very high gain.
I assume that's also causing all the noise I see in the image. How grainy it looks.
Yes. That's correct. Hey, Steven Smets with us. Good morning. That's Mr. Django from Belgium. And he's on vacation. Thanks for sharing your vacation with us, Steven. We have people from all over the world that join us. It's really nice, you know. Blaine, J. Blaine 19 says, I wouldn't know what to do with a telephone and a camera. You mean a telescope and a camera together. I was old school, backyard telescope with a dark sky, looking at the moon and planets. Always thrilling to me. I think that's pretty cool. Yeah. My first telescope was a 2.4 inch refractor, so the lens was about that big around. And I actually built a mount for it, an equatorial mount, using plumbing pipes. I made a pipe mount, and it was heavy as all get out. But I could actually follow the stars with it. It was really cool. James Hyatt, welcome. Good to see you again. Yeah, Science Bob, with the computer running the scope and using a guide scope, that makes life better. It does, but you got to keep in mind that we're also doing this remotely, and that was a whole nother bag of tricks. For people that may or may not know, we're getting a lot more detail in this nebula now. Look at that, Daryl.
Yeah.
May not know. This telescope you see in the building up there, that's 2,600 miles from me. It's out in the Arizona desert, and I'm in Connecticut, so I'm all the way across the country running it from there, broadcasting to the world, and then going to skytourlive.org with all the data. So to get all that working, it took me about a year of trying focused intensity to do it, and I actually had to write some software. This right here, which I'll show you. This right here is a program I wrote. That's our observatory program, our observatory protocol program that I wrote to do that and manage everything in the observatory, like simple things like rolling the roof off the building had to occur, right? Notice up there that the roof has come off. There's no roof on the building. That's it right there, and it rolled off the building. How do you do that? Well, you interface to something called a relay, and you have the relay connected to the opening system, which is right there. And you basically, I had to hack into the electronics to actually get to the part where, if you have the relay clicks there, it'll open the garage door, kind of a thing. And then turning on power to the telescope had to happen. I also, which I haven't shown you yet, I have this camera here. This is our all-sky. This all-sky has all kinds of data on it, and we can overlay constellations and see where things are in the sky. All right. We can go back and look at previous nights. Okay, like if we just scroll down here. Okay, here's last night's time lapse. This goes from early morning all the way to the next day, early morning, right? So rather than bore you, there's the clouds going through for the day. And as we get to the stars, okay, let's just go back here. Okay, so there we go. Then stars come out, and we see satellites zooming over. We'll see some planes too. There's the Milky Way, of course. And it's really very pretty. There goes some aircraft and or stars. Notice something else, okay? If you noticed down here, the clouds are black. Now, clouds are usually bright in the sky, aren't they? But this is a dark sky site, so the clouds are silhouetted against the Milky Way and the stars in the sky. It's actually kind of cool. All right, the time here is just after midnight, going on 1 a.m. at that time there, and if we stop it here, you can see this is the North American Nebula in Cygnus the Swan. This is Cygnus. And you can see Deneb is here. And we have this star here. We have these two here. And then Alberio down here, which is the tail. So this is Cygnus the Swan. And it's really pretty. And if you notice, that's in the northwest. Over there, there's our compass rose. All right. Then down here we have Altair, we have Vega, Deneb, and Altair. These are the summer triangle stars. Very, very cool. You know, so we have, if we look at it, you know, this way, we're looking at Deneb to Vega, Vega to Altair, and Altair back to Deneb. This gives us our summer triangle.
Except that's not
Deneb's not. This is Deneb. I screwed up. Yeah, from here. Yeah, sorry about that. So this is our summer triangle right there. Yeah.
I always think of the summer triangle as the big slice, and
pie.
It's pizza, yeah. So when it wasn't pretty much an isosceles triangle, I knew something was up.
Yeah. And then as we go, we'll see meteors on here. We'll see all kinds of things. We actually see some really interesting UFOs as well. And I'm the Mutual UFO Network's chief photo and video analyst, so I see a lot of crazy stuff here. Now here comes, it's 3:20, 3:30. Here comes Orion. There's Orion. Okay, here's the Pleiades. Let me crispen this up. Okay, there's the Pleiades right there. Okay, here's Orion right here. I believe that's Jupiter.
Yes.
And I think Saturn is up here somewhere.
No, Saturn's in Eastern Aquarius.
So, Mars then. Is it Mars?
Yes.
Okay, I think that's right here. If I might be. I think that's Jupiter and Mars. And then we have Orion the Hunter, Betelgeuse. You can actually see it's kind of looking orange a little bit here. And this is the Hyades. Here's Aldebaran and the Hyades, the V shape here. Okay. That cluster is actually kind of close to us. Aldebaran's actually closer to us, I believe.
Yep. Yep. Hyades are about 170 light years away,
Yeah.
and Aldebaran is a foreground object about 70 light years away.
Yeah, this bright star down here is Sirius rising, I believe. Unless that's an aircraft coming through. Let me just make sure. Oh, yeah, it's Sirius.
Yeah, that's Procyon above it.
Yeah. So, that's it. So, this is Orion. You can actually see the Orion Nebula right there. Okay, right there you can see the Orion Nebula. And this is the winter Milky Way. See this? Now the summer Milky Way is gone, but now it leads to the winter Milky Way. Very cool. All right, so let's get back and see what we got going. Let's see what we got brewing here. Oh, look at that.
There you go.
That was worth waiting for. That was worth waiting for. Let me color correct one more time. Oh, look at that, guys. That's really pretty. Very, very nice. Yeah. And this is Linstark Nebula 673. Such a beautiful object. Just has a little numerical designation, right? Yeah. Oh, and Bob, you were right. On the left side of the night sky image there, you saw the light pollution of Phoenix, 75 to 80 miles away. Now, with your eye, you don't see it. In fact, it's so dark you can't see in front of your face. However, when you actually take into account that this camera on the all-sky camera is extremely sensitive, and it's a 15-second exposure, you're going to see the light pollution from a long way. And that's what we see. So here's this beautiful dark nebula. Now, while we're still getting some images, we only have 26 here. And to get something half as noisy, noisy, you have to use twice as many exposures, rule of thumb. So we have 26. If we wanted this to be, half as noisy, we have to go to 52. We won't, but I'm just saying. I can artificially remove the noise quite easily. Yeah, I built that all sky camera, Bob. It's a ASI 678 MC Pro camera, and I made sure that it's actually in the box, and it has drying agent in there to keep any moisture. I had moisture when I initially put it in. I also had birds sitting on the dome of the all sky. We had bird butts, images of bird butts, so we're looking at it straight up. So we put a little spinner out there, a professionally made spinner thing that prevents the birds from sitting on the dome and scratching it with their little feet, you know. Yeah, Izabela might be lurking, Mr. Django, Steven. But she let us know. Oh, is Renee here? Did you say Renee was here?
Yeah, she's here. She typed up a fancy message with a lot of emotes and says this message is held for review.
No, sir.
Yeah.
Well, did it get released?
Oh, there, right there. See her?
I do
just
not.
Just below Science Bob.
Oh wait.
And just above me.
You mean down at the bottom? Where you?
No, about halfway up. A little more than halfway up.
Oh, okay. There's Renee Cruz. Okay. Nice to see you, Renee.
The YouTube, I guess, objected to all the
emojis. Well, look, and that's how Renee wants to talk to us. I say we let her talk to us that way. I'm okay with it.
That's why I hit the show button.
Good for you. Thank you for doing that. Yeah, Science Bob says loves the fisheye camera. Yeah, that's really nice. All right, you're starting to see a lot more detail in this. This is really something. If Izabela is lurking, I'm sure she's going, look at that. Izabela's really good at doing processing with us as well. And so aside from writing the application that we're trying to get out there, it's also true that she's an artist and also very accomplished as an artist and one of our best image processors. Really cool.
She's going to be running this place someday.
We say that, don't we?
Yeah. She's a smart cookie.
Yes. Izabela, if you haven't figured it out, we're trying to get you to just say hi in the chat if you're lurking. Evan B. Daniels, how you doing? He says, what's the oldest light/object you have identified in your travels? Excellent question. We actually were looking at galaxies that were upwards of 85 million light years away. And those aren't the faintest objects we could see. We could see other objects that are fainter, but they're very disappointing to you guys because they're like little dots. Well, we know they're galaxies, and we're like, look at that, we can see that galaxy. And you're going to look at it and say, it looks like a splotch, man. It's a tiny dot the size of a star. But they could be 85 or 90 million light years away. And that means that the light that left them to come here left 20 million years before the dinosaurs died to get here. And it was traveling through space all that time. Isn't that incredible? Just outrageous. Now you can see, Daryl, how there's more down below here.
Oh,
What
yeah.
I was saying. Here's a nice little dark area condensing over there. And we have a satellite trail that's being overwhelmed by the stars finally again, and the darkness behind.
And
Okay.
you can also see some of the lighter parts of the dark nebulosity.
Yeah, right there you
Yeah.
can see. And you have to do it with this kind of thing. Now, I'm only doing, again, a 25-second shot. Realistically, I should be doing like a 4-minute shot. But do you really want to sit through that to see something that Daryl and I would go ooh and ah over, and you just say, well, come on, man, let's see other cool things. You know, I'm going to take them up to a couple of cool things after this. All right, we got time. All right, good. So we'll save this and save it exactly as seen. That's at 40 exposures. So now the noise in here is half as much roughly as if we had just done 20 exposures, which we typically will do. So that's good. So we're gonna leave this guy alone. As pleasant as it is, it's beautiful. All right, so we're gonna leave deep sky mode, go into low light mode, and pump up the volume. There we go. All right, now look at that. You don't see anything, but what we saw was like an incredible amount of additional detail in that field that we hadn't seen before. Let's get rid of that there, and we're actually very close to let's go up and maybe try this. That's what I wanted to do before.
Oh, the Tulip. Okay.
Yeah.
James Small, we cannot see Proxima Centauri or the rest of Alpha Centauri at all. We're too far north. It's below the southern horizon.
Yeah. Cygnus is like directly up above us right now. So our best views of Cygnus are going to be like on a night like tonight. I think the Tulip is right here. I'm going to make a guess that it is, and I'm going to move us over to the west a little bit.
It was pure coincidence. Mark imaged the Tulip fairly recently, and like a day or two later, APOD had an image of the Tulip Nebula in Cygnus, and it pointed out that Cygnus X1, the black hole, is in the same image, and I guess we didn't know that the first time, and we actually identified it in the SkyTour image.
That's right. That's pretty cool.
And if we get a good look at it tonight, we'll point out Cygnus X1 for you.
I think we will. I'm going to go at 450 again and do a longer exposure of this. Actually, you know what? We want to see Cygnus X1 as well. So I'm going to drop us to 400. And this time, I'm going to go with a 30-second exposure.
Cygnus X1 was the first black hole discovery.
Now you're making people think they're going to see a black hole.
Well, what we'll see is a star, 2 stars.
Right.
Cygnus X1 is one of the brightest X-ray sources in the sky, I believe it is.
That's why it's X1.
Yeah. And the musical group Rush actually did a song about Cygnus X1.
With my
6 stars of the Northern Cross and mourning for their sister's loss.
with my favorite drummer.
In a final flash of glory, nevermore to grace the night. Neil Peart.
Yep. Favorite drummer. Some of you may know this of me. I've been a drummer for years. And my drum teacher was a guy named Chris Wink, who went on to found Blue Man Group. And he was my teacher for 4 years. And I knew he was strange even back then. But very cool.
All right, I can see it right now.
Cygnus X1?
Yes,
Yeah. Is it here?
down to the left. Those 2 stars close together.
Right there?
Farther down, those 2 stars close together. Right, those 2 right there.
Okay.
X1 is the lower of the 2. The upper star has a blue color, and the lower star has a yellow color.
Okay.
And the yellow star is where Cygnus X1 is.
Okay. Let's get color rendering here. And we should see the I want to see the blue shell that Cygnus X1 might have expelled.
Jay Blaine, we do not know. We check it regularly. The last I saw, it still hadn't gone off. It's a nova, not a micronova. It's just not a supernova. It's a regular nova. He's asking about T Corona Borealis.
Yeah. I don't know if we can see it right now. It might still be up. But I chose to take it. It's probably not going to be up right now. Look at this. I mean, at this... I'm seeing... No. Is this it? Is this the blue bubble?
It's bigger, and it kind of extends to the upper right.
And this is going to the upper right.
It extends farther to the upper. It's kind of a narrow bow shock.
Yeah,
Bow shock.
It is a bow shock, yeah. Bow shock, yeah.
It's skinnier and it goes farther up. I'd have to go back and refer to that image to figure out where.
I thought it was about that size and ovalness, but maybe I'm wrong. It's kind of in the right place because you got Cygnus X1 right down here.
Yeah. Well, to the left for
Yeah,
Cygnus
right
X1.
here. Right there.
No.
Yeah, no?
Cygnus X1?
Yeah, where it was
The 2 stars close together to your left
here?
is higher up. Right there. Right there.
Oh, is this one? Is this Cygnus X1? That guy with the orange?
Yes. The yellow one is the
Oh,
Cygnus
okay.
X1.
All right.
The one above it is kind of a blue color.
'Cause I do see a blue haze here. See it?
Vaguely.
Actually, let's pump this up to see if there's something there.
Let me go find it.
Yeah, look. There's a blue haze right here. Right there. That might be it. Look at all the detail in here, guys. This is amazing. All right, it's there's only eight photos here, so that we've stacked. Let's zoom in. By the way, this is the Tulip Nebula. Okay, now that said, this is Cygnus X1 right there. And if you want to see it, it is that star inside the box.
I am going to drop it in your
All right.
chat, Mark.
See, this is what I was talking about. This guy right here looks like this blue bubble coming off here. But we'll see. We'll see. Neato.
Well,
See right there? Let's let it resolve a little bit and see if we can.
I'm looking. I dropped the picture in your chat, Mark.
I know, I'm looking for it.
Okay, if you see there's a fairly bright blue star to the upper right of Cygnus X1, and the leading edge of the bow shock is just about touching that blue star.
This right here?
No, way up, way up.
This one?
That one. The bow shock extends up as far as that star.
Oh, as far as that star.
Yes.
Okay.
And it arcs off to the left and the right on either side.
All right.
There is a brightest area in that bow shock on the right-hand side, which is to the upper right of Cygnus X1. You might be barely catching it.
Yeah. We should let it go a little longer to catch that.
James Small. My name is Darrell, Darrell. I am in Colorado.
And his other brother, Daryl.
Yeah, I never heard that one before.
See? I knew it.
Jay Blaine, we were talking about that just recently.
What do you ask?
Betelgeuse possibly having a companion star.
Oh, yeah.
I would say the jury's out. I think it's possible. It's, as I understand it, if I read it correctly, it's probably inside the outer envelope of Betelgeuse.
I would think it would have to be.
Yeah.
I mean, from a celestial mechanics point of view, that could explain why we're seeing these outbursts from Betelgeuse. They may not be outbursts at all. Right, so there. Let's see. Yeah, that's okay, yeah, because these stars right here, right there, they are some distance, and this looks like the edge right here, the edge of this blue. As it gets brighter, it curves up, it looks like that. Let's see what our increase can show us. Let's really pump it. Well, we're seeing some stuff in there. Fascinating stuff. That's cool. This line here comes down, and when it gets down to about here, it touches just the edge of one of these bow shocks. You can't see it, but it's like a loop that goes like this. And I'm curious why it's not going the other direction as well. Very cool. Nice, nice, nice. Okay, let's see who has questions in here. Well, Jay Blaine asked that question about Betelgeuse. And what would happen if it went nova? It would get so bright that you'd see a second star during the day in our sky if it was in the daytime sky. In the nighttime sky, it would actually just be a bright star, the brightest star in the sky.
Brighter than any star in the sky.
Except the sun, of course.
Well, yeah. And Betelgeuse would be a supernova, not a nova or a micronova. It's a full-blown supernova.
And not quite a kilonova.
There you go.
Yeah. Very, very cool. Very, very nice.
Sure is colorful.
Yeah, it's got a lot of color to it.
Interesting what a gain of 400 will do for you.
Yeah.
Will you be able to tame that and process it?
Oh, yes, yes. Alright, I've just color corrected again. And you can see the edge of the blue loop here.
Okay, Jay Blaine. So what would happen to its companion star when Betelgeuse goes supernova? It might fling the companion star right out of the system.
Yeah, that's true. Now, keep in
It
mind...
might continue orbiting. It's awfully close, though.
Yeah.
It's like two some odd Betelgeuse radii away from Betelgeuse.
Which could end up with a... it could disrupt that second star, too.
Yeah.
But I'm not convinced it'll disrupt that star. It depends on the nature of the other one. And some darkness in here. Oh yeah, this definitely, you can see the blue in here, Daryl. Definitely see the blue in there. Let's drop this down a little bit. Alright. Let me drop it in this. Okay. A little noise in there. Well, there it is. There's the whole tulip. And nothing but the tulip. This is 24 shots. At a fairly high setting for the gain. By the way, just so everybody realizes, because I don't know that we may know this, maybe you don't. When we look at what we're doing here, one thing to keep in mind is that here along the bottom here we see the details on the sensor, and I don't know if you can see it right here, but the temperature of our sensor is minus 11 Celsius, but it's actually 30 Celsius out in the building. Okay, it's 30 Celsius right there in the scope room there. But it's minus 11 at the sensor because we're actually cooling the sensor quite substantially. Yeah.
Got down in the 40s here last night.
Yeah.
First time this year.
Yep. Yeah, James, as Daryl just pointed out, it's a 10-inch diameter scope, and it's not like a 12 or 14 or 16 inch. That's our goal. I love a 22 inch, to be honest. I saw one at Starzona, by the way.
What's that?
I saw a larger. I saw like an 18-inch or something, or 16, I think. At Arizona when I was down there. It was for sale.
What make?
Oh, it was a Richie Creighton.
Oh.
Open truss tube. Makes the break between a seeing things and not seeing things when you're really going for some deep objects.
Well, I've said before, there's you cross a line
Yeah.
at about 12 or 13 inches aperture where the view through the telescope just changes completely.
Yeah.
It's like a quantum leap.
Yeah, for sure. All right, this is cool. Let's see what it wants to do. Yeah, I figured it's going to back it off.
It got down in the upper 40s here last night, first time this year.
Yeah.
This is the best time of year in Colorado. The monsoon seems to be breaking. Getting mild, sunny days every day, and
Yeah.
we might get rain in a couple of days, they said, but
Yeah.
typically this is the best time of year in Colorado.
Yeah.
Mild, sunny days and clear, cool nights.
Yeah. All right, I got 30 exposures. We'll end it at that on this one. And I'll get out of it, and we'll go back to our low light mode. There's our low light mode. And let's check this out now. Now, I have to do this. And I apologize ahead of time to Ray. Cosmic Ray. He always complains when we go to look at this filamentary nebula. We talked about a supernova. So I'm gonna want to show you a supernova. And we will do the eastern veil because it's really the most beautiful. And the central veil is actually gorgeous. This is a supernova, right? And it's many moons across in diameter, and the moon is a half a degree. So it's the number of moons across. I forget, is it 4 or 5? All right, so now we're gonna go here and check it out. There it is. Right there. Beautiful, beautiful. You know, the first time I saw this was in the telescope here in Connecticut, and it showed up. And I was doing it with an inferior camera, and it was just the most beautiful thing I've ever seen. I saw the colors for the first time in my life. That was just a few years ago. So now, some of the people watching us are going to see this for the first time in theirs. This is the eastern veil. You're looking at it right there. It's actually basically the left half of an expanding sphere of material. Okay, you're just looking at the left edge. That's why it looks brighter. Okay, and it's called the eastern side because it's on the east side of this. And the Veil Nebula because it kind of looks like a bridal veil. And we're going to go to a 25-second shot. And to start off, we're guiding. Go into our live stack, and I'm going to get rid of this. Go into low light mode. There's our totally blown out thing. We're going to be playing with that to try and tease out details.
Awesome. We see a face too. You used to call it Alfred Hitchcock, but the nose is wrong. Looks more evil than Alfred Hitchcock.
Well, it ain't Gru. Look at that, guys. Look at that. In just 25 seconds, you see a gorgeous object in the night sky. And those colors are real colors. And that's at 400, by the way. I'm gonna drop this back down to 250. No, I'll do 300. Let me just clear it and let the next one come in at 300. We'll do 300. 300 was the maximum I used of the other camera, because that's all it could go to. This one can go to 450. Michael Hendricks got a question. If the sun is suddenly gone, would the Earth only feel the lack of a gravitational pull after 8 minutes?
Yes.
Yeah. That is correct.
Speed of light, you can also call it speed of causality.
Look at that. Wow, this never disappoints. Let's darken up the background by riding up that white curve until we get to near the peak. And that's beautiful. Look at this. You can see all kinds of...
there you go.
Yeah. I can zoom out a little bit so you can see all of it. Okay, that's the image so far. I got just the top, just the bottom. There's the eyes, the cheeks, and the nose, and the mouth.
Awesome says Joker.
Yeah, that's true.
I can see that. Got an evil grin.
Yeah. All right, let
Looks
me...
like he stuck his nose in a pencil sharpener.
I know. Okay, there's the color correction. All right, isn't that beautiful?
When you see the different colors, those are different elements.
That's right.
The red is hydrogen, the blue is oxygen.
Yeah, it's really more of a green. The bluish color sometimes casts to green. I'm sorry, the green color normally sometimes will cast to blue. It's really more of a greenish blue color here, but it's a really beautiful view. If you look in here, you can see that we have all these wisps, and these wisps are okay. Now let's go back just a minute here. Let's look back now and think about what a supernova is. When a star ends its existence, it could either go quietly by swelling into a red giant and shrinking down to a white dwarf. In the process, it usually leaves a shell around it of its outer layers, known as a planetary nebula. When the star is more massive than a certain amount of mass, just a little more than the mass of the sun by a few times, then a star, when it runs out of fuel to do nuclear fusion, will undergo what's called a core collapse. The interior of the star will collapse. And that's really dangerous, because what happens is, as the core collapses, it's trying to take all this material that was already under immense pressure and put it into even more pressure. Temperature skyrockets, and at the same time, neutrinos are made. Neutrinos are these little particles that are able to race right through you and through the planet Earth without any problem, and we can only trap a few at a time when we try to trap them in these large underground cavern tanks. And the neutrinos get out first, and when we see neutrinos coming from a place in the sky, we know a supernova is underway. And because the stars that are going supernova are usually so big, the supernova is occurring inside the star. The star is already dying, it's already dead, and this shockwave of materials moving out, the neutrinos get out first, and we'll see them a few hours before we actually see the actual supernova, because it takes hours for that shockwave inside to reach the outside of the star. When it finally bursts out, the star disrupts as we call it, and gets destroyed, leaving this. All right, this is one piece. Now, again, it's a shell. It's a spherical shell. If you look at my hands, it's like a spherical shell, and on the edges, you can't see through my fingers. So that corresponds to the areas where we can see lots and lots of wisps overlapping each other. But when it's in the front, you can see through my fingers. It's thinner and more delicate and wispy, where the wisps seem to be separated more. And the other side, similarly. So as the sphere of expanding gas is moving outward, it's moving out into the interstellar medium, but it's not just empty space. It's colliding with stuff. The glow you see here of this expanding remnant could very well be from the collisions that this gas is suffering with the interstellar medium and other debris and other dust. And that would raise the temperature millions of degrees. And that temperature rise could result in the ionization of hydrogen, making the glow, and the ionization of oxygen, making the other glow, the blue glow. All right? So that's one of the processes. But the wisps themselves could be the result of collisions with material, but they could also be due to something else that's been, it's an ongoing research, actually, field right now. And that is that maybe these wisps are the result, and I'll zoom in on them right here, some of them. It's possible that these wisps are created because of electrical charges running through this rarefied gas, moving at high speed through the interstellar medium. So we could be looking at a electric nebula. You know, as Khan said, perdition's flame, Captain. I hear what you're saying, Khan, but no. So you see those beautiful wisps right there. That's really, look how delicate they are. It's possible that we're looking at electrical shaping of some of these tendrils that we're looking at there. Very, very possible. Look at that.
And if you want to see wisps, you haven't seen anything yet.
I'm talking about the Western Veil?
Yes.
Yep. Yeah. But from here, we're going to go to the Central Veil. Okay, this is 16. Now, the thing is, this is so bright that we don't need to go to like 50 and or more exposures. We can stop here at 20 in just a short time. I'm going to color correct one more time, because as we take pictures, sometimes the response changes. As you can see, it just did. And then I'm going to move the black level. Notice this black level. I'll show you what happens if you move it to the very top. Okay, you're going to see it get really dark, right? But if I move it further to the right, now it's going to start clipping out pieces of the nebula, till finally you're only left with the brightest parts of the nebula, which you see right there. Right there. Those are the brightest parts. We don't want to clip out. We want to leave it and it shows it, because you can actually go, well, really, really dim, and then really, really bright. Zing. And then zing. So right there is that's right at the very peak, and we typically ride just a little bit to the left of the peak, and the reason is because there's subtle detail in here that gets lost if we don't. Wow. All right, so we're coming up on 20, and here we are, S20. And now we'll save it. It seems the wind has abated. We haven't lost any exposures here. See the 0, 20, and 0. So 20 taken, 0 skipped. And we'll save exactly as seen.
Stuffy said it looks like Bob Hope's nose.
Oh, it's true. The ski slope. Hey, Stuffy, how you doing? All right. So now, Western Veil is going up to the server. And now we're going to go back to our low light mode. There's the cutover. And then we pop it up. And now I'm going to go and take us to the central veil, which is really unbelievable. This central part. We're going to go right there.
Pickering's triangle.
You got it. Pickering's triangle. It's a triangle area that's actually quite beautiful. You can see the nebula in here. See wisps in here. Let me see where we are and make sure that Pickering's triangle is in here. Yeah, we should see it. It's right there.
Yeah.
Now, do I want to go a little up or just leave it here? I'll try this and we'll see what we get. Same amount of exposure, 25 seconds. And I'm just going to kick it north a tiny bit. This first one might be a throwaway because I moved it. Telescopes don't like to be moved when you're taking pictures of them. There's the eastern veil. We'll clear that. Let's see what the western veil looks like. I'm sorry, the central veil. Oh, okay. So that tells us everything. That it's the bad shot, but there's Pickering's triangle with more detail. Actually, that might not be a bad image. Maybe I'll move it over a little bit. Yeah, I'll move it over a little bit. There it is. You'll see that in a moment. Really pretty. All right. And we're just going to move to the west a little bit. That's good. Lewis Ta, yeah, it's too bright, but I did that so I could see it. All right. Now we're going to do this again, and this will be really pretty. 25S underway, and off we go. We're in low light mode. Let's get out of low light mode and cut over to deep sky mode. There's deep sky light right here. Yeah, that's what we're going to do, but that's now in the center more. So we'll clear that. I had moved it. That's why it looks like that.
Pickering was the director of the observatory where it was discovered.
Yes.
Pickering got credit,
But he's not the guy that found it.
but he's not the guy that found it. The poor schmuck at the telescope found it, and Pickering got all the credit.
Yeah, evil guy. So there is this central veil, and this feature is called Pickering's triangle. Keep in mind, okay, this is not flat. This is three-dimensional. So there's three-dimensionality here. This could be a part of the nebula that's heading away from us or heading toward us. So it could be going away or toward us. It's in the middle. So it's going away or it's coming toward us, one of the two. I think the research has been done to show which side of the supernova this is. It could be a mix of multiple pieces, actually. Yes, it looks like Groot. I am Groot. Absolutely. This is pretty. This is looking nice. Let's color correct. There we go. And let's see where it wants to go. It's going to do that pull back. So you can see faint wisps here. Supernova. Now this is light years across, guys. So about 8,000 light years away. No, sorry, wrong. I think it's like 1,800 light years away. Happened about 8,000 years ago, if I recall. And in that time, that material has expanded through space. It's gone many light years in all directions. And again, this material left the star. It was very hot when it left the star, but it could have cooled off and stopped glowing for a period of time, and then hit other material in the interstellar medium. And when it did, and this is only the stuff that's showing. There's all kinds of stuff that we don't see in this supernova. And it's amazing how supernovae spread elements to the stars like this. Because the supernovae will make elements that we see in our periodic table. All right, and many of those elements are in you, and many of those elements were made in supernovae, in the hearts of stars, and it became something that was made with the planet when it was made, and made with life when the life arose on that planet. That's just a cataclysmically spectacular nebula.
You know, I've gone looking repeatedly for the source of the supernova.
Yeah.
And evidently it just completely blew up. There's nothing there.
Well, there's Cygnus X5, which I thought was the remnant of this.
Oh, is it?
I think so. Check it out. Look at this right here. There's like a pillow right here of material. That's really interesting. We've never seen this before. Very nice. Okay. Very subtle colors. This is just beautiful. I'm going to darken this up a little bit now. Go about halfway back. That's something, guys. That's really pretty. Now, one thing to keep in mind is that in the universe, elemental abundances are very important. How much of certain elements are around. And as it turns out, in the universe, the most abundant element was hydrogen. The next most abundant, helium. And there's some lithium and beryllium, of course, made during the Big Bang and so forth. But then, the fourth most abundant, and those are in small amounts because they decay from other isotopes. So hydrogen is number one, helium is number two. The third most abundant element in the whole universe is this stuff right here, oxygen. Okay, third most abundant. Fourth most abundant, right, is carbon. What you're made of. Carbon is what life is based on, and that is owed to the flexibility of the carbon atom. It has these four what they call valence electrons. You can attach many different things. It's like tinker toys with atoms. It's so cool. You can build millions of different combinatorial compounds with a carbon atom and multiple carbon atoms in different rotations and orientations. Because the rotation matters, orientation matters, angle of attachment matters. It's a very, very complete picture we have of the carbon atom. And it's the fourth most abundant element in the entire universe. So it stands to reason that being so flexible, that life is based on it. And I'm a carbon bigot, I don't mind telling you. I don't believe that there's life based on silicon. I just don't. If you look on the periodic table, you have carbon, and then underneath it you have silicon. And so that column represents elements that are most like each other in characteristics and capability. So the next one, next possible closest one to carbon is silicon. But silicon makes very robust bonds. But it can make more bonds, right? But they're very robust. So you just passed the meridian. Okay, so that means the telescope just passed the meridian just now. So like when you walk on a beach, that's titanium dioxide. That's sand, all right? A titanium atom with 2 oxygen atoms. All right. Now try to break those oxygen atoms off. All right. I'm sorry, a silicon dioxide. So why did I say titanium? I'm getting tired. Silicon dioxide. Sorry. All right. So try to break those oxygen atoms off the silicon atom, and you're gonna have a hard time because it's extremely tenacious, and that's the problem with silicon bonds. They're very tenacious. They tend to make good, solid crystal lattices. So you're not going to be able to break those apart easily. Carbon atoms, on the other hand, as you're sitting here watching this show, you've got tens of thousands of carbon bonds being made and broken inside your bodies as you speak. So it's actually really interesting, how that works.
The Horta in Star Trek with silicon.
I know, and that's about as far as it gets, right? I love Dr. McCoy. Jim, I'm beginning to think I can cure a rainy day. and Shatner before Kirk, he said, "Bones, you're a healer. Fix it."
Didn't Bones?
Oh, what?
Didn't Bones say, "I'm a doctor, not a stonemason," or something like that?
He goes, "I'm a doctor, not a bricklayer."
There you go.
And then he said, "Bones, you're a healer. Fix it." And when I was working on, when I was on a show called The Unexplained, which is hosted by Shatner, and I did my Shatner impression on the set. They laughed, so it was kind of funny. Look at this. This is pretty.
But you'd been waiting all your life for that moment.
Well, I know. I had to get Shatner back, okay? And the reason is because he knocked my father on his butt. I went to see him at one point, and he actually came barging out of the stage door as my father and I were walking by, and I'm a little kid, and I went to see Captain Kirk, and all he talked about was Shakespeare. It was boring as heck, all right? But Captain Kirk came barreling out of the door and knocked my father right down. And he goes, I'm so sorry. And he picks him up, brushes him off. And my father, he doesn't care. He went there for me. He didn't care. He's just some actor. That's all for him. That's all it was. He goes, I am so sorry. And he went back in his cranberry-colored Monte Carlo car with New York plates on it, okay, and sat there in the driver's seat, okay. He was alone. And my father's leaning on the window talking, and I'm sitting back there going, my dad's talking to Captain Kirk. Oh, my God. My dad's talking to Captain Kirk. I can't believe this. And then I got home, and all I could tell my mom was, Dad got to talk to Captain Kirk because he knocked him on his ass. And my father was like, not exactly. He's a very nice man. I was like, it's Captain Kirk. Yeah, Denny Crane with mad cow disease, right?
Yeah.
It's mad cow. Medco.
That was funny when he got robbed. Mugger tried to rob him, and Teddy pulled out his gun and shot him in both legs or something.
I remember that.
If you go back to old movies, he was in the Twilight Zone episode with the
Nightmare
guy seeing the monster out the airplane window.
Terror on the Wing or something like that, or Nightmare on the Wing, or Nightmare 30,000. I forget what it was.
If you ever saw the Spencer Tracy movie, Judgment at Nuremberg, Shatner played, he was a U.S. military officer. He was a JAG or something, I forget what. I will never forget, I was in Germany back in 1990 on business for several weeks, and I was sitting in my hotel room one night. They played a lot of B movies on German TV.
Okay.
They love B westerns over there, and they showed a movie. I think it was called White Apache. And Shatner played two roles in the film. They were twin brothers. One was a guy who grew up with the whites, and the other was a guy who grew up with the Apache Indians. They were fighting each other.
Oh, okay.
And it was a really silly, corny B-Western. Shatner's war paint looked like 60s racing stripes on sports cars from back then.
Well, the other thing is, you know, Shatner is kind of almost synonymous with schlock, right? Shatner schlock. I mean, fighting the Gorn, right? In Star Trek, it was like all slow motion. Kirk could dance around and beat around. They could just run away, for crying out loud. The Gorn's like, I will be quick and merciful.
Yeah, that was pretty bad.
James Small, no, I didn't say anything during the filming about the fact that I had met Shatner in that way, because I was just a little kid at the time, and during the filming I was focused on being an astronomer, because that's what they needed for the show, and I didn't go down the path of, you knocked my dad on his ass, you know, or that kind of thing, so that wouldn't have been professional. Although I did think of it, I didn't say it.
I saw hints of a certain broom earlier on in this image.
Yes, you did.
We going there next?
Yeah, it's right down here in the corner.
Oh, don't give it away yet.
We're getting there. And then, let's see. Look at this, guys. Look at this beautiful central veil. Isn't that beautiful? Okay, we're gonna just save this here. I'm gonna first change the name. Very important to make sure we get the right name here. This is the central veil, as opposed to central casting. Alright, central veil.
I looked up Cygnus X5. I found exactly one entry for it on the first page of Google.
Okay.
And it really said nothing at all.
Yeah, I think Cygnus X5 is.
Excuse me.
I think Cygnus X5 is the remnant left over from this explosion. Okay. This is up there now. And let's get out of that and go to our low light mode. He's dead, Jim. Yeah, the silly stuff we grew up with. Hey, it wasn't good science fiction, but it was all we had. Okay, now I don't have to actually use coordinates because I can actually see the object we're going to. It's right here.
My favorite Star Trek babe was Sherry Jackson, who played Andrea in the episode What Little Girls Are Made Of.
The android, yeah.
Yeah.
Yeah, she was a little demure blonde.
No, she wasn't. She was a brunette. You're thinking of somebody else.
You're right. I was thinking. I do remember that.
She had on the black and blue striped sort of pantsuit that didn't have a whole lot covering her upper portion of her body.
Oh yeah.
That was the one where Ted Cassidy played the big monster.
Oh yeah, he played Lurch in space.
Yeah.
Yeah. Yeah, many people think the classic TOS, the original series, was better than Next Gen. I've got to admit, I like Captain Picard. I like that,
The first season was lame as hell.
Yeah, Encounter at Farpoint was the very first episode, and I was like,
That was all.
No, that's a bad entry for Star Trek. No.
They went all the way to the last show of the season, first season, when those little bugs from outer space were crawling inside people and taking them over and making them super strong and stuff. When they blasted the guy with phasers at the end of the show,
Oh yeah.
and his head exploded.
And all the little buggies came out.
Yeah, that show was considered so graphic the BBC refused, or they wouldn't show it on British TV for a long time.
Okay, we're here.
And the whole tenor of the show seemed to change after that.
Yeah.
Okay, here we are.
Yep. All right. We're in low light mode. We're going to get out and go into our stack mode. And we're going to change this to its name, which is Western Veil, after we clear Central Veil. Now you'll see what the Western Veil looks like. This will be very pretty as well. And here it comes. Boom. Bah. Ah, look at that. In order to show the bottom here, we've actually got to, allow the little tip at the top to, it's just barely there, so we're okay. Here's the remnant of the central veil, and then this is the western side. 52 Cygni is this star. That red halo is an artifact of our optical system. We get rid of those in post-processing. Oh yeah. I'll color correct here. Hope you guys are having a good time tonight. By the way, Goblin, I forgot to say hi to you. My apologies.
I have a soft spot for green Orion slave girls. Always have.
So did Captain Pike, and look what it did to him.
Oh yeah.
Yeah.
I didn't care much for Enterprise, but they had some really hot green Orion slave girls in there.
Yeah, Scott Bakula wasn't that powerful a captain. He was better in Quantum Leap.
Yeah. There was one episode where they had 3 green Orion slave girls on the ship, and they did a little dance at one part. I thought that was just hotter than heck. I have a green Orion slave girl figurine a friend gave me for Christmas years ago.
Well, you remember Buck Rogers in the 25th Century with Aaron Gray, Wilma Deering.
Oh man.
Yeah. Now the show was terrible, but I
beady.
That was Twiki. Yeah, Twiki. Yeah. Beady. Howdy, Buck. Shut up, you little round piece of whatever, you weird shape. Anyway, that was Felix Sia. That was the operator of that little robot, little small person. Well, anyway, I was eating dinner because I had done some work for the Boston Red Sox where I restored a ship called the Draconia, which was the flagship of the evil queen in the show. And
oh, she the one that said, I want Buck Rogers.
Yes.
Yeah.
Yeah, the brunette lady with that
Yeah.
overabundance of makeup and lips. Well, anyway, I was eating dinner one day when the phone rang and answered the call, and the guy said, "Do you know who this is?" I went, "No." He says, "It's Gil Gerard. You know, Buck Rogers." I, "Oh, Gil, what's going on?" And so I had a nice, like, half-hour conversation with him because he found out I restored it and he wanted to talk about it for a little while. He was actually at a conference, and he took time out to give me a call. It was so funny. It was like a Comic-Con, I think, where he was. And, you know, they get tired of sitting at those tables, so I can't blame them. So then about 20 minutes later, I just finished dinner. Right, phone rings again. And it's Aaron Gray. "Mark, this is Aaron Gray. How are you?" I go, "Oh my gosh, Aaron, it's so nice to talk to you." And so she talked to me for about like 15 or 20 minutes. It was hilarious. It was great. So I got to talk to them both. It was really cool. Ask them if they know me today. Not at all. They don't remember me. Okay. They talk to so many people. But it was actually nice, you know, to be able to talk to them.
Wasn't the bad girl Princess Ardala?
Yes.
Wasn't that her name?
That's right.
Yeah.
Yes.
I want Buck Rogers.
That's right. I want him here groveling at my feet. Yeah.
Then they brought that guy Hawk on, and I
Yeah,
knew
that's
when
when
they
jumped the shark.
jumped the shark.
Yeah, feathers over his head. It was like, oh. Yeah. Imagine being cast in that part. "You're going to be the guy with feathers on your head." "I am?" "Yes, you are." In the words of Worf, as old school say, "I will not do it, Captain."
Warriors drink.
It's like, "I would rather stick a baton in my eye." A batlev in my eye.
Oh, don't you remember Warriors drink?
No.
It was when Whoopi Goldberg gave him prune juice.
Oh.
He drank it and he looked at it and he goes, "Warriors drink."
Mr. Worf, that's prune juice. Yes, Worf, that is prune juice. Thank you, Mr. Data. Yeah, Worf was a great character in there. So we got 13 shots here. Look at this. Daryl was talking about you haven't seen nothing yet when we talk about wisps. Let's zoom in and just kind of take a tour of this beautiful megapolis. Again, all of these wisps could very well be related to electrical charges coursing through this rarefied, meaning thin, but still dense enough nebula that electrical charges could be transferred through, and they could be causing these wisps. And that's research still going on, so it's pretty cool. This star is up in the foreground. That's up here. It's the nebula's way back here, so we ignore that star. Many times people look at this wisp right here and they say, "Oh wow, this star must be doing it." No, this here is a good 1,000 light years past that star. If I don't miss my guess, I'm not sure how far up, how far away 52 Cygni is. I don't remember. You can easily find that because the nebula is about 1,800 light years away. I've heard estimates of 1,500, 1,600, 1,800. At one time, they thought that the supernova happened 18,000 years ago. Now they think it's 8,000 years ago.
Give me just a second, I'll find out.
Yeah.
52 Cygni?
Yeah, 52 Cygni. So we come down, you'll notice these wisps. You'll notice these two. Look at these subtle wisps here. Okay, this is all expanding shell, guys. And because, you gotta remember, this is in 3 dimensions. So what's going on? We don't know. This wisp we're looking at right here, it could be looking at us on edge like this. It could be kind of 3/4, or maybe it's going around an edge and we're seeing it as it curves around an edge. We don't know. It's not perfect. Go ahead, Daryl.
One place says 52 Cygni is 291 light years away.
Yeah.
Another place in the very same article says it's 201 light years away.
All right, so let's say 225. Okay. The nebula is about 1,800 light years away. So, again, that number changes too. Okay, so let's move our curves over a little bit and then just take our midline. Move the midline and it helps remove noise. See that? See how much softer it looks and how much more detail it looks like you can see? That's sometimes great because we can suppress noise with this mid-level. A lot of the noise occurs in that mid-level, so we can take it out. Claudio Ramos from Chile is with us. C. Ramos, how you doing, man? I think you're talking about the Vera Rubin telescope, southern Chile. Is that the one? I actually applied to be the outreach astronomer on that project, but they wanted somebody different. I'm too much fun.
You have to have a PhD to push a broom at places like that.
Yeah. All right, so this, you can see all this beautiful detail.
I see some faint wisps there on the right.
Yeah.
I don't recall seeing before. That one and that one.
Yeah, yeah. I had mentioned that just a few minutes ago. I said, look, we can see these beautiful wisps too.
Yeah.
Yeah. Again, as I mentioned, these are all expanding shells. And they all came off pretty much at the same time. So it's happening that it's hitting other material out there, which is why it's slowing down and looking separate and distinct. Fantasy, thank you for coming out. So good to see you, brother. You have a good night, and thanks for coming, man. This is pretty. So now remember, guys, all these pictures will be available to you to take and utilize whenever you want. They'll be up on the server at skytourlive.org. Go up there, go to the section that says Take Me to Cool Pictures, and then you can see these raw shots. Patreon subscribers, for the upper level Patreons, they get the highly processed final imagery, and they get the mosaics when we actually put them together to make one big photo of multiple images. They get those as well. So it might be worth doing that if you want to join our Patreon. So there is our annotation.
I always wondered at the twisted appearance of the upper part of the witch's broom up there. I always say it looks like a tornado or a twister.
Yeah.
I'd almost say what could do that? You were talking about electrical, electric charges shaping the nebula.
Could have been, yeah.
If any place, I would think maybe like that. That kind of reminds me of a prominence on the sun.
It does, yeah.
Which is all entrained in electromagnetic fields.
Yeah, I don't know. See, that we have to, again, think of this in 3 dimensions. We don't know how deep that goes into the page, so to speak, and how far out it comes. If we saw it from the side, for instance, it might look like this. But from our perspective, it looks like this, you know. So it might look like that from the side. And the electrical charges might not be in play at all. We don't know. Good night, Fantasy.
Looks like twisted rope to me.
It does. It really does. And we zoom in on it. Now that we've got 28 shots, we'll go to 30. Look at that. Look at that. That's only 66% on the sensor. We got a very large sensor. So we can go to 100. There's 100%. There's 100% of our sensor right there, guys. And you can see some really cool details. And we will remove a lot of this noise. Look at that. And those faint wisps. Because we're at 300 sensitivity, Daryl, these wisps show up much cleaner now.
Yeah.
Okay, so... And Cygnus is, again, look at the telescope. Cygnus is directly overhead. Wow, nice. Darn it all. Yeah, you know what I'm doing.
I'm about to turn into a pumpkin, as Michael H. said earlier.
Okay, well, I put it up there, and this is gone, and we're gonna be in low light mode again. All right, well, I am going to fool everybody and do one more object. You knew I would. It's just one more. When I get to the end, it's one more. All right. I would like to look at one more object. Spock, we're gonna view one more object. Fascinating, Captain. All right, we're gonna go up to Deneb here. And let's go right here. Oh, let's go that star. You watch the telescope shift a little bit now. Or not. May not have caught that. All right. Okay. There it goes. Oh yeah, lots of nebula in here. All right.
Excuse me.
Okay, so gotta do a quick 20-second shot to see what we're looking at here. Wait, that was this. I gotta go back to our live view here. All right, there's our live view. We're looking right here. That's where we're looking. Okay. Now let's go back here. Ooh, okay. That looks like I want to go just a little bit south. This is the Gulf of Mexico. That's Florida. This is the North American Nebula. This is the wall. Let's go see that. So we're going to do that. And we'll do a short sequence here. Because Daryl's turning into a pumpkin.
Yeah.
Alright, so we're just going to drop it south now. This will be the best shot of it. we can possibly get because it's straight up. There's the wall right there. You can clearly see the wall. Okay. We'll take that picture of the wall. Alright. And we'll do another, just 25 seconds. At 300 sensitivity, so it's actually pretty high sensitivity. And off we go. Not much to see there, is there, right there? No, not a lot. But we'll come into a live stack now. Get rid of the previous shot that we had, this beautiful image there. Now, let's see what we get. Wow, that's really pretty. That's the upper part of the wall. This is the beautiful dust. This is all dust that's in the region. It's here in the foreground, and the rest of the nebula is behind it, so it's obscuring what's behind it. Let's back out a little bit so you can see the whole bit. I'm gonna color correct. Look at that. Look at this little squiggle of black. That's dust. Now that dust is like probably that tiny little dust squiggle. That's going to be, a light year or two across. So we're talking this major area of space is full of fascinating stuff, but it's massive scales. It's just massive scales. Oh yeah. Okay, so that's cool. So this is a good night, Daryl.
Yeah.
Okay. And this will be North America Nebula. It doesn't have citizenship. Like Canada geese, it's Canadian geese, it's Canada goose. North America.
Nasty critters.
Yeah, my sister has a farm and she has geese as watchdogs. I'm not kidding.
Say if you want a good watchdog, get guinea fowl. I guess those things really make a racket.
Yeah, and they chase your ankles. Lewis says it's a beautiful nebula. Yes, it is. Yeah.
When you see the dark cloud there, and then the illuminated portions of the nebula to the left of it, some say that there are bright stars behind that cloud that we can't see that are what's lighting up the North American Nebula.
I think that there are research has shown that there are some stars in here that seem to be the progenitors of the hydrogen excitation here. This almost looks 3D. This almost looks 3D here. Look at that.
Don't make me say it.
No, you're not gonna. Alright, so now, let me get rid of this for a moment. And let's just check it out. Let's enjoy the glory of this nebula right now.
Boing.
Couldn't resist. That really looks beautiful, though. That's a gorgeous shot.
It is.
Yeah, and I'm okay with the 300 now. We normally use a 200, which is 100 less, right? Look at this.
I thought you usually ran about 250.
Yeah, sometimes, yeah. Look at these 3 stars.
Somebody told you not to go past 100 on gain.
Oh,
a while back. That seemed to affect you for a while.
Yeah, no, I know, but I was looking. It was actually the optimum gain for this particular camera. But I wanted to go and reach for some fainter objects. So I've used it at higher. But there's details we haven't seen before, like, look at this shape right here, and look at this stuff right here.
Yeah.
These spikes of dust. Look at these tendrils. These we've seen before, but these are now showing so well. Very nice.
Lewis and James, you're not looking at Florida here. You're looking at Mexico and the Yucatan.
Yeah. This is the Gulf of Mexico. Florida's up here. It's out of shot to the upper left.
Upper right.
That's what I meant. My other left. Yeah, I'm getting tired too.
Yeah.
Oh yeah, really pretty.
Looks like a very busy place.
Yeah, sure does.
When you're looking up towards Cygnus, folks, you're looking basically at a right angle to the center of our galaxy, and you're looking up toward the next spiral arm.
He's talking about right there.
Yeah.
And this will continue around to Orion.
Right toward Deneb. And that's why there are a lot of stars in there.
Yeah. You can see the Sagittarius star cloud down here. And then let's that's the Scutum star cloud. Sagittarius star cloud just out of view, just getting there. So we have the Scutum star cloud. That's where Messier 11 is, that we will often see right here. In fact, we might be able to see Messier 11. I think that's it right there. That might be it.
When the teapot in Sagittarius is up, if you point your right hand at the spout of the teapot toward the center of the galaxy, and then point your other hand up toward Deneb, your arms are making a right angle to each other, literally 90 degrees.
This is really pretty. Hey, Waldo Hiding, how you doing? Nice to see you. I'm gonna bring the telescope back here, and I'm gonna dock this again, because we're gonna drop the size a little bit. That's just absolutely beautiful. Let's color correct this one more time. There we go, that's more natural colors. We'll do one more shot. This will reach us to 20. Claudio, may I ask you, what do you enjoy? What do you enjoy most when looking at and scrolling through everything you find about? Oh, well, actually, Claudio, when you look at nebulae like this, okay, I'm a big fan of the pink, H2 regions, the hydrogen alpha regions, because there's usually stellar nurseries. But this dark nebulae, this is where it's at. This is where life begins. Life begins in the dark. And so this is one of the hot buttons I have is this. Look at this. This looks like a Shogun warrior with his fiery eyes. He's got his arm raised here, his arm raised here, and he's got that Shogun toga thing on. There's his legs. And the helmet with the little horns and stuff on it. Or that's a wolf.
Or a werewolf.
Oh, yeah.
Albert Einstein supposedly said, "My sense of God is my sense of wonder at the universe." That's what I get out of looking at stuff like this.
Yeah. I mean, this, because it's directly overhead, we're seeing more detail than we've ever seen. Let's zoom in here. Look at that. We'll get rid of this noise. Very subtle details in there. Boy, oh boy. Our Benson telescope is going to be... one that we're going to be able to do a lot of other things as well with. We'll talk about that another time. Alright, it's Wolfman Jack! Yeah, that's Wolfman Jack. Alright. I lied. I said I was going to stop at 20. I'm going to stop at 25. Because I'm at 300, 300 gain. I want to have a little extra buffer for noise reduction. The more you stack, the less noise you get. Okay, there we go. Excellent. Well, there you have it, folks. You've done it again. You've wasted a perfectly good evening with SkyTour Livestream. Hope you enjoyed this. These pictures will be up here, skytourlive.org. Make sure you check it out. And I'm going to say right now that it's time for us to go bye-bye. And we'll talk to you again. So good night, everybody, and have an excellent evening. Or morning. So see you later.
Good night, everybody.
There you go. All right. Good night, folks.